All right, flipped video, chain rule. I'm on page 33. How do we differentiate a composite function? So a function that's made up of a function inside of another function. So obviously you can't do that part because you're at home watching a video. We can do that in class maybe. Not important though. The chain rule allows us to differentiate functions that look like this, composite functions. So we're saying there's some capital F function that's made up of g inside of a little f. This is the chain rule. This is actually what the chain rule says. And this is going to show up in many applications on the AP exam. So knowing this formula early is a great thing. What this says is when we have a function inside of a function, we take the derivative of the outer function. The f becomes f prime. We leave the inside alone. That's still g of x. But then we multiply by g prime on the outside. And that's what I have right here. I'll say it 1,000 times on this video and in class. I call it a huge important concept. Take the derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. So the common mistake that people make is they take the derivative of f prime, they take the derivative of g prime on the inside, and they don't do anything like this, and that's wrong. Sometimes we'll have more than just f of g. We might have like f of g of h or something fun like that. So we're going to work our way from the outside, leaving the inside alone, and burrow in, burrow in, burrow in. Okay, we're going to do some examples of that. So this is just an intro to chain rule. These are going to be the most basic chain rule problems that we're going to do. So we're going to do all of these problems on page 34. So I'm going to move the paper so that I can start some problems. So square root of x squared plus 1. Probably need to switch this to being a power, because that's the only way we know how to take a derivative of a square root. So the outermost function is the 1/2 power. The inner function is the x squared plus 1. So for example, if I wanted to write this as a composition of functions, I would come up with two functions that look like the pieces of this. If I take the h and put it inside of the g, if I put it in right there, I will end up with my f. So f is g of h of x. The outer function is that 1/2 power. The x squared plus 1 is going inside, so that's the inner function. So that's just to kind of give you an idea of what's going on. We're not going to do that every time, but just to kind of give you a picture. So what I'm going to do from here, f prime, I'm going to use power rule for the outside, right? The outside is a 1/2 power, so I'm going to use power rule. Bring the exponent, bring the exponent in front, decrease the exponent by 1. Leave the inside alone. Then I multiply by the derivative of the inside. Now this is showing more work than you'll probably show once you get comfortable with the chain rule. You'll probably just figure out what that derivative is instead of writing this here, which is what we're going to do in the next step. What's the derivative of x squared? 2x. And then I can cancel the 1/2 and the 2. If I were doing this on an FRQ, I would leave it. I wouldn't even cancel that. On multiple choice, this is going to look like that. So it's a matter of just being able to recognize on multiple choice. So let's move on. B. So again, I have a function inside of another function. X squared plus x is inside of the sign. Sign is the outer, x squared plus x is the inner. So when I'm taking the derivative of this, I do derivative of the outside. Derivative of sine is cosine. Leave the inside alone. This is the step that people mess up. Leave the inside alone. Then multiply by the derivative of the inside. So I could write it like this again. But I think we know the derivative of the inside, I hope. What's the derivative of the inside? So you've got that, and then probably best idea would be to write it so that that 2x plus 1 doesn't look like it's attached to that. This is the angle, this is actually the coefficient of cosine. X squared plus x is representing the angle in this problem. So not too bad, right? Let's look at C. So what's the inner function on this problem? Inner function. So the inner function is the x squared minus x plus 1. The outer is the power of 3. So I do the derivative of the outside using the power rule. Move the exponent in front, decrease the exponent by 1. I leave the inside alone. And then I multiply by the derivative of the inside. What's the derivative of the inside? So like that. And they might switch the order of these just because typically we write from smallest to highest power. So 3 is power 0, right? 3 times x to the 0 is the same as 3. And then that's first power and that's second power, but I don't want to waste my ink. It's not worth it. I would recognize it on multiple choice. I would get it right like that on free response. Okay, jamming. So here is kind of a trick. So remember, I've mentioned this once before. We only deal with 2 variables in our level of calculus. So we are h of x is like our y, and x is our x. What does that mean about a? That means a is a constant. So when I'm taking the derivative of this, it is not 3a squared. A is a constant. I know I have my y and my x, and that's it. So this is a number. Derivative of a number is 0. Now, before I go any further, let me come back up here. Cosine to the third, so notice in the notes here, things that are squared. So cosine to the third, or any exponent really, I shouldn't have said squared there, means cosine, I don't need a bracket there, to the third. The entire cosine is being raised to the third. So this is, again, a chain rule problem. The outer function is the 3, power rule. Leave the inside alone, then multiply by the derivative of the inside. The derivative of cosine is negative sign. So h prime is negative 3 sine cosine squared. And I'm done. Okay, so let's do a few more. I don't know if I have time to do all of them. Let's see. I don't want this to be longer than 10 minutes. Okay, outer function is sine, inner function is 7 minus 5x. So the derivative of y, derivative of the outside, sine is cosine, leave the inside alone, multiply by the derivative of the inside. Derivative of 7 is 0. Derivative of negative 5x is negative 5. And again, if this were free response, I would leave it just like that. But because I am a little bit of a perfectionist, I'm going to write it like that. Okay, this one's tricky. Oh, this one's tricky. Notice that this is secant of tangent of x. This is not secant x tangent x. It's not secant of an angle times tangent of an angle. What this is whatever the angle is, I would take tangent of that. Then whatever that answer is, I would take secant of that. So this is a composition of functions. The derivative, the outside is secant. What's the derivative of secant? The derivative of secant is secant tangent. Usually, we just say the derivative of secant x is secant x tangent x. But our argument in this problem, our angle, so here it was an x, right? Well, it's not just an x anymore. So whatever that argument in the original is what comes through in the derivative. So the derivative of secant tangent is secant of tangent. Well, that angle is going to stay the same. This is like our equivalent of leave the inside alone. Then we multiply by the derivative of the inside. What's the derivative of tangent? Secant squared. And there's really no way to make that look prettier. So secant of tangent of x, tangent of tangent of x, and secant squared. This is not tangent squared. So side note, tangent of x is not, let me do my little magic trick, tangent squared. Tangent squared is tangent x times tangent x. So hopefully you can see the difference there. It's tricky. It's definitely tricky. Okay. Oh, I'm past 10 minutes. We'll save G and H. I think we can save G and H for the next time. I think you get the gist of chain rule. Hopefully. All right. Asta.